Geometry students, no new theorems today, but we are going to practice graphing lines and writing equations of lines as we study parallel and perpendicular lines. So remember, our last lesson was about slope. Slope is the change in y over the change in x. Just incidentally, I may have glossed over this or maybe even didn't say it, but the Algebra 1 students have done this, and so they should know. The reason we use the letter M for slope is the original mathematician to write this stuff down, to be talking about the coordinate plane, was French. It was Descartes, famous for saying, "I think, therefore I am." And as a French mathematician, it made sense for him when he studied lines to think about how lines climb. And the French word for climb is monter. So when we talk about M for slope, it's because a French mathematician said, I should use M because that's the beginning of the word climbing. And so we're talking about how a line climbs, whether it goes up or down or doesn't move at all or is a straight vertical line, which we define as an undefined slope because the denominator would be 0. So first we have to be able to find slope between 2 points. So remember, this comes from some x1, y1 on a graph and some x2, y2 on a graph. All that matters when you find slope is that whatever y coordinate you use first, you have to use the corresponding x coordinate. So if I gave you the points 3, 2 and 5, 7, the only mistake would be is if you did 7 minus 2 over 3 minus 5. You would have to do 5 minus 3. 7 minus 2, so then you have to do 5 minus 3. You could do 2 minus 7, then you would have to do 3 minus 5. Either way, you end up getting 5 halves. One way you get 5 over 2, the other way you get negative 5 over negative 2. Either way it reduces to negative 5 halves. Well, the next thing we're going to look at is how would you graph that line? Well, pretty easy when you know 2 points. 3, 2 and 5, 7. To graph a line like that, all you would really need to do is remember that any 2 points are a straight line. So we had the point 3, 2 and 5, 7, correct? So you could easily graph this line by going to the point 3, 2 and going to the point 5, 7 and graphing those 2 points on a coordinate plane and then just connecting the dots. That's a pretty easy way to graph an equation of a line when you have 2 points. Another way of graphing a line is when you have it in certain forms. So we're going to talk about 3 forms of a line. My favorite, which is called point slope, then there's slope intercept, and then there's standard form. You need to know how to work with any 3 of these forms, and you also need to know that most lines, actually I think all lines with the exception of vertical and horizontal lines, all other lines can be written in the form point slope, slope intercept, or standard form. So you can have 3 different representations of the exact same line. Think of it this way. We've got Daniel in dress uniform, we've got Daniel in non-dress uniform, and we have Daniel in his pajamas on the weekend. It's always Daniel, he just looks 3 different ways. Could look like dress uniform, could look like regular uniform, or look like he's in his PJs, his civvies. So lots of ways to do this. Let's just get into it and make sure we can graph from any form. The most complicated, but I think the most easy also over time with more exposure is point slope. So let's take a look at point slope. Point slope says if you have a point x1, y1, and you know the slope, you can write the equation y minus y1 equals m times x minus x1. So let's take the example we just had. We knew m was 5 halves, and we knew a point on that line was 3 comma 2. So to write that line, we could just say y minus the y coordinate equals the slope times x minus the x coordinate. And you're done. That's it. To graph this, the tricky thing is to notice that it's the point 3, 2, not -3, -2. So it has to be a minus sign there. And then you would just go to that point and use the slope. So you would go to 1, 2, 3, 1, 2, and then you would go up 5 and over 2, or you could go down 5, 1, 2, 3, 4, 5, and back 2, right? Lots of ways to use the slope, and whoa, I missed that one terribly, but you got the idea. That's how you would use point slope. You would actually take this point from the graph, 3 comma 2, or from the equation, and the slope, and go to that point and just use the slope in different ways. Let's try another example. So here's an example. If I told you y plus 1 equals 3 halves times x minus 5. Graph that line. All right. So hopefully you paused the video. If not, pause it now and graph the line. Okay, here we go. So the point would be 5 comma -1. And the slope is right there in front. It's 3 halves. So the way that would work is you could just go to the point 5, 1, 1, 2, 3, 4, 5, comma 1. From that point, go up 3 and over 2, or go down 3 and back 2, and connect the dots. A lot of you may remember from Algebra 1 something called slope-intercept form. Slope-intercept form is y equals mx plus b. It's called slope-intercept because m is the slope and b is the y-intercept. The y-intercept is the value of y when x is 0. Pretty easy to see that if you make x equals 0 and you solve this equation, n times 0 plus b, you're going to get b. So what makes this equation so nice is if you have something like y equals -3/4 x plus 5, all you have to do is know, oh, this is in slope-intercept form. So 5, 1, 2, 3, 4, 5 is the y-intercept. I go down 3 and over 4. Or I go up 3, that's positive 3. So then I have to go backwards 4. And now I have that line. So a lot of people love slope-intercept because it's just so easy to graph from. Take the example we just had before, something like y plus 1 equals 3 halves times x minus 5. If you distribute the 3 halves and then solve this equation for y, it will be put into slope-intercept form. So just to see that, that's y plus 1 equals 3 halves x minus 15 halves. Subtract the 1, and then you end up getting y equals 3 halves x. 15 halves minus 1 is 17 halves, -17 halves. So that equation has a y-intercept of 8.5, -8.5, and a slope of 3 halves. Not always easy to graph a fraction as the y-intercept, but you could if you were careful. So let's try another example. Try this one on your own. If I told you that y was equal to -5 thirds x minus 2. Pause the video and graph that line. Start with saying the slope is -5 thirds. That means down 5 and to the right 3, or up 5 and to the left 3. The y-intercept is -2. So you go to a y-axis, you go down 2, you draw a dot, there's your y-intercept. Then you go down 1, 2, 3, 4, 5, and over 3. Or you go up 1, 2, 3, 4, 5, and backwards 3. You can probably hear my dog barking at somebody. Out! Out! Sorry about that. And then you connect the dots. All right. My last, the last form of a line is called standard form, ax plus by equals c. I love this form because it's easy to graph by finding the intercepts. So take something like 3x minus 4y equals 12. The way you want to graph this is first pretend that x is equal to 0. This would be finding the y-intercept. If x is equal to 0, then this term goes away, and you just get negative 4y equals 12, so y equals negative 3. That's a point on your line. 0 for x, negative 3 for y. Now you do the same thing, but you pretend y is 0. If y is 0, now this term goes away, and you're left with 3x equals 12. That means x equals 4. So there's another point, 4, 0. And now you just connect the two intercepts, and you're done. Now what you don't get with with standard form is nobody tells you what the slope is, but you can find it. It's up 3 and over 4. So this is 3/4. That would be the slope. And so there are your 3 lines. Here's a practice one for you just to make it complete with everything. If I told you 5x plus 2y equals 10, graph this using the standard form method, finding the two intercepts. Pause the video, do that now. All right, so if x equals 0, 2y equals 10, and y equals 5. If y equals 0, then 5x equals 10, and x equals 2. They don't always switch like that. I've just picked numbers that make it so it works that way. So now when we do this, we get something like 0, 5, and 2, 0. And then the slope down 5 over 2. All right, thanks for watching. I know it's a little bit longer video, but it's done and it's going to be uploaded before 4, so peace.